It's hot sauce. Yes, go ahead. Okay. So anyway, definition of a vertical asymptote. If the limit from the left of some x value or the limit from the right of some x value is either infinity or negative infinity, then you have a vertical asymptote there. All right, zooming out. Okay, so make sure you write that down.
I can see pencils in your backpack.
Okay, so right here. If the limit as x approaches c from the left or the right is either infinity or negative infinity, then x equals c is a vertical asymptote. So it's kind of a different definition. I don't know if you've ever even learned a definition for a vertical asymptote before. So you've learned methods for finding them, but now you actually have a solid definition. So if the limit as x approaches some c value from either the left or the right approaches infinity or negative infinity, you have a vertical asymptote at that value of c. So for our first example today, I'm going to give you no instruction at all. I'm going to see if you can do this
That's kind of rough.
just with your groups from pure pre-calculus knowledge. All right? So I want you to find all vertical asymptotes for the function g of x equals x squared minus 3x plus 2 over x squared minus 4. All right? So find all vertical asymptotes using any method you wish.
Hey, don't tell me what to do. You're so rude.
Okay. Get my face out of there. And then switch the screen out.
Alright, so there's a whole
You decide what is a vertical asymptote and answer appropriately.
and there's a vertical asymptote
That's worse than the bottom.
right? I can check. I wrote this down in my notes like 80 million years ago. Don't even try me, Jacob. Check this out. Are you ready, Jacob? It's about to get hammered into your brain. Alright, vertical asymptote. Zero's on the bottom. It's a negative two.
Feel free to talk to each other, work together.
I didn't really say that. And then with horizontal degree, they're the same.
I think we're
Leading coefficient, they're also set to 1.
it's
There's a horizontal
Some people are already done, some people are still writing down the problem.
The horizontal
Right.
It's really
weird.
It's like when you're like upside down position, and you're like right now.
There's one every single day.
All right, anyone need another minute? You got this? No. What are you doing? You're still writing down the definition.
I have to find my proper binder because I don't look at it.
Goodness.
Yes,
You might want to label
four
them.
identical binders. Why did you think that won't? Why didn't you buy 4 identical black binders?
Okay, so guys, when we're finding vertical asymptotes, what's the first thing that we do? Factor, right? So we factor everything, and what does the top factor into?
X minus 2.
Minus 1, what's the bottom? Plus 2, x minus 2.
Oh no, there's a hole.
Oh, no, there's a hole, right. So, okay, so we have a vertical asymptote. Let's see, 0's in the denominator, so -2 and 2.
No, there's a hole.
Which one's the hole?
2.
How do you know?
Because there's one on the top.
Because there are common factors top and bottom. When you have common factors top and bottom, that gives you a hole, not a vertical asymptote. So this one would be a hole, right? So the only vertical asymptote is at x equals -2. Make sure you put the x equals, because a vertical asymptote is an equation of a line, right? Okay, not just a number. It's an equation of a line, and it's a vertical line, so it's x equals -2. All right, good. Any questions on that? Now we're going to learn how to prove it's a vertical asymptote by actually finding the limit as x approaches -2 for this function. So, when we find the limit as x approaches -2 for x squared minus 3x plus 2 over x squared minus 4. If we plug the -2 in, well, let's see here. We get 4 plus 6 is 10 plus 2 is 12 over 0. In the past, 12 over 0 would mean you would just write what? DNE and you'd move on, right? No more. So now you don't get to just write DNE. Now we know that 12 over 0 implies there's a vertical asymptote, and we need to check the limit from the left and the right. Because it could do one of four things, right? It can go whoop, it can go like that, it can go whoop, or it can go whoop, right? Okay, so you know what I should do is turn this
So you did the first step.
like
and
that.
then you did the next
Yeah.
step.
So just so I can see, hey, I'm right on camera, so that's good. All right, so anyway, all right, so it can do any of those four things, and we gotta know which one it's doing. There's an easy way to do these left and right-handed limits. And you know what, before I even start, I am gonna go ahead and factor and cancel common factors. So we have x minus 2, x minus 1, x minus 2, x plus 2. So when we're doing the limit, we are allowed to cancel common factors because in the limit world, this limit is equivalent to this limit. Okay? So you can do that. All right, so now we're trying to find this. So I'm going to find the limit as x approaches -2 from the left of x minus 1 over x plus 2. Now, I'm going to start this by saying this is not a piecewise function. This is a standard rational function. Because this is a regular rational function, I know that this function is going to approach either infinity or negative infinity on both sides of the vertical asymptote. If it was a logarithm, it'd only be 1. If it was piecewise, it could be who knows what. But here, regular rational function, it's got to go either up or it's got to go down on both sides. So I know this limit is going to be infinity. I just don't know if it's positive or negative. If I do the limit as x approaches -2 from the right, I also know it's going to be infinity. I just don't know if it's positive or negative. How do I figure out if it's positive or negative? There's an easy trick to figure it out. So I pick a number close to, oh, whoops, I've been writing this wrong. There we go. I pick a number close to -2 from the left. Pick a number close to -2 from the left.
-1.5.
From the left of -2.
Oh.
-3.
Okay, -3. -3 is decent. I want to get a little bit closer. -2.1 is perfect. All right, -2.1. I'll show you why we want to get a little closer than an integer way in just a moment. So we're going to try -2.1. And all we're going to do is check the signs. So if I plug -2.1 in on top, the top is
-1.
negative. If I plug -2.1 on the bottom is negative. A negative over a negative is a positive. So this first one is positive. You don't have to put plus, but you can. Positive infinity. I'm going to pick a number now close to -2 from the right. -1.9. So if I plug in a negative 1.9 on top, I get a negative. On the bottom, what's a negative over a positive? Negative. If the limit from the left is positive infinity and the limit from the right is negative infinity, then the limit is actually DNE because it's not the same from both sides. Alright, so here now you can write a true DNE. So from this moment forward, if a limit is actually equal to or approaches infinity, you have to write infinity. You can't just write DNE. So if it approaches negative infinity, you have to write negative infinity. No more DNEs. And if it approaches something totally different from both sides, then you can write DNE. So let me give you an example. Oh, first steps. Okay, so steps for vertical asymptote. So here's what you're going to do. Steps. All right. Steps for vertical asymptotes. This is only for vertical asymptotes. If you plug a number in and get not 0 over 0, that's what tells you there's a vertical asymptote there. So you're going to check the limit from the left and right. The answer is going to be positive or negative infinity. How do you know? You just choose a number close from either the left or the right, plug it in and check the signs. Okay? That's right. Erase this. I bought board cleaner and then I left it in my kitchen. So I will bring it tomorrow.
Is the other one out? They have the
It's completely empty.
You try unscrewing the top and like upside down.
I'm just using hand sanitizer. It's a really nice sanitizer board here. Okay. Okay. So let's do another example. So we're going to do the limit. In your homework, some problems will say find the vertical asymptote, but some problems will just say, hey, find the limit. So we have this over this. Okay, so we're doing the limit as x approaches 5. X squared minus 1,000 over the quantity x minus 5 squared. First thing we do is we plug in a 5, and we get negative 975 over 0. So what does that tell us? Specifically, what do we got at 5? We have a, what kind of an asymptote?
Oh, vertical.
We have a vertical
My bad.
asymptote. Vertical asymptote. As soon as you know you have a vertical asymptote, you are in left and right limit world. So we have to check from the left. And we have to check from the right. Everyone take a second. All you're doing is plugging in and checking the signs. See, don't overcomplicate it. You don't have to find the actual numbers. Take a second. Pick a number close to 5 from the left and a number close to 5 from the right and see what you get for both. And then see if you match your neighbor.
It'd still be like 5.1.
Yeah, 5.1 or 4.9. Yep, depending on which side you're on.
From the left, you mean? Right this. Right. The book negative. Yeah.
That's what I got.
Alright, Jacob. No need to pretend like they're the smartest person in the room. Yeah, we don't want that to happen.
Okay, so if I pick a number, what's a number close to 5 from the left?
5.9.
4.9. 4.9 squared minus 1,000 is that?
Negative.
That's negative. The bottom is always what? Why? Because we're squaring it, right? So we get negative over positive, that is darn negative. Alright, pick a number close to 5 from the right. 5.1. Square it and subtract 1,000 and you are negative over a, oh look, they're both negative infinity. So what should I write for my limit? Negative infinity. If they match, that's your limit. If they don't match, it's DNE. Does that make sense? Let's try one more. Okay, we're going to do the limit as x approaches negative 2 of 50 minus 3x squared over x squared minus 4.
Oh.
Eight.
Okay, so when you plug in, do you get 0 over 0? Not 0 over 0? What do you get? Not 0 over 0, which means there is a vertical asymptote, which means we need to check the limit from the left and right.
I would still yeah, to right.
Yes, which means we need to pick a number close and check the signs.
Yeah, that seems about right. Alright, I don't need your stats and stuff.
No, no mental. Paper, pencil, right.
Stuff just got called out on its lazy. Make sure you check your answers with your neighbors. But you don't have to hide your paper, it's not a test. This is the test.
I got negative.
It's just a test. And Jacob's obviously gonna.
I did negative 3. And you got positive negative 2.
Bro, I haven't even copied down the work yet, so.
Or from the
Oh, it'll be negative.
Are you not a big notes person?
I'm taking, just writing down the notes. It's all positive over.
Take your time now.
What do you get?
Whoa, so you get positive as the first one. Yeah. Bro, don't slap me with stuff, but that's not cool.
Yeah, that's what I got.
So it's positive and negative.
Sounds good.
Negative eliminates. Yep. So it's D and E. Jacob, you don't ask if you're this one. Jacob, do you know Davis got on his last test? He got a 98. He actually should have got a 95 though. Yeah.
Alright, when in doubt, at least put an infinity because you got a 50-50 shot, right? Okay, so we plug in negative 2 from the left, what would be a number? Negative 2.1. Okay, so I get 50 minus something around negative 12, right? Something like that, 57, 12, something around there. It's going to be what? Positive. So the top is positive. Negative 2.1 squared is something bigger than 4, so positive. We have a positive over positive. It's going to positive infinity. If I pick something close to negative 2 from the right, like negative 1.9, the top is still positive, but 1.9 squared is less than 4. So the bottom is going to be negative, which means what would I put for my overall limit? D and E, because they don't match. They have to match.
Do we have to write not same from both sides, like on the quiz? Or?
If it asked you why, the answer would be because the limit as x approaches -2 from the left is not equal to the limit as x approaches -2 from the right.
Ooh. That was pretty sassy.
Alright? Good. Now, one more quick thing. I know we're packing up. The bell's gonna ring in just a minute. But why do we have to pick a number that's like that close? Why can't we go an integer away?
Yeah.
Because if we look at a graph of a function with a vertical asymptote, a lot of times what happens is it'll come along, say the asymptote's here. So the function will come along and it'll go like that. And so if you go an integer away, say that's -1, -2, if you plug in all the way a whole integer away, you might be negative. But it's going to positive infinity. You need to pick those numbers really close so that the sign actually reflects what's going on the function, right? So anyway, that's why, because sometimes it can cross the x-axis when you have a whole integer away. So it's a trick. It's not like a valid, perfect mathematical method, but it's the fastest, easiest, and